All right, here's a more complicated practice problem. Here's a graph of f prime and some nice landmarks to judge things against. So we're asking, where's the original f increasing? Where's the original f decreasing? Where does the original f have a local min? Where does the original f have a local max? And is there anything else interesting going on? So take a sec to decide which intervals the original f is increasing or decreasing, has a local min, local max, and be very, very careful, lots of people get confused on this, to not be thinking about where f prime is increasing or where f prime has a local min or max. Think about the original f, which is not sketched here. All right. You can write the increasing or decreasing intervals either in interval notation or just by highlighting intervals on the graph. I actually like highlighting intervals on the graph more. So what can we say about this? Hopefully you've paused and done it for yourself. What can we say? Where is f increasing? Well, from here to where, we can say f prime is positive, so f is increasing. That goes up to 10, right? As far as we know here, f prime is positive, 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 even though f prime is decreasing, f prime is still positive. So f itself is increasing all the way up to 10. And then from 10 up to where, we'd say f prime is negative, so f is decreasing. All the way up to 20, f prime is negative. Even though f prime is itself increasing here, f prime is still negative, so f itself, so the original f, is decreasing. And we seem to have a pattern here, so we'd say over here, f prime is positive, f is increasing. And then what about at 30? What would you say there? At 30 itself, f prime is 0, and then from 30 onward, f prime is positive still, so f is increasing. So maybe I'm just the only person who does this. If something has a positive or increasing feel to it, I usually write it kind of above the line, and if it's negative or has a decreasing feel to it, I wrote it below the line. I put my little tick marks at the end of the intervals here, going up or down, just to give that feeling to it. You can do it whatever way works for you. Also here, f prime is 0. Here, f prime is 0. So we've marked out which intervals the original f is increasing or decreasing. Now let's think about where the original f has local mins and local maxes. So what about this spot right here? That's where f prime equals 0. That's a critical point, right? And can we say that's a local min or local max? Now, some people would say, well, it's not a local min or local max. This is a local max, and that's a local min. Those are local mins and maxes of f prime, but we're asking about the original f. There's a problem like this on the homework that gives lots of people a bunch of trouble, so it's worth trying to figure it out now. So here, f prime is 0. So that's going to be a local min or local max. F was increasing, so we know the general shape of f was increasing, and then here the general shape of f is decreasing. So we think this is a local max of f, and we could use the first derivative test as a formal way of saying if f prime goes from positive to negative, then the original function has a local max. And then over here, the original function must have a local min or max again, because f prime is 0. I actually should have shown this transitioning to being increasing again. It should have been smoother than that. So this should be a local, let me write that better, of f. This would be a local max of f. And then what about over here? F prime is 0 there. So we know the original function has a flat tangent. And then what can we say? Well, the original function keeps increasing after that. F is increasing from 20 to 30 and from 30 onward. That's what we have here. And so is that a local min or local max? Well, you might remember the word saddle point. That's a saddle point, not a local min or max. So that's what I meant when I said other there. So taking a graph of the derivative, using that to figure out where the original is increasing and decreasing, not getting confused about where the derivative is increasing or decreasing, or has a local min or local max. One other quick question here. What are the critical values of the original function? Take a sec to think about that. So is 5 a critical value of the original function? Because this has a horizontal tangent there. But remember, this is f prime, not f. So where the f prime has a local min or max doesn't matter. It's where f prime is 0 or dne. Those are the critical values. So the critical values of f are at 10, 20, and 30 here. Since f prime is equal to 0 there. And there are no places where f prime fails to exist. All right.